Hi, I'm Jelly and I will be discussing about limits. In mathematics, a limit is the value that a function or sequence approaches as the input or index approaches some value. Limits are essential to calculus and mathematical analysis in general, and are used to define continuity, derivatives, and integrals. Limits are the core tool that we build upon for calculus. Many times, a function can be undefined at a point, but we can think about what the function approaches as it gets closer and closer to that point. This is the limit. Sometimes we can't work something out directly, but we can see what it should be as we get closer and closer. We have here an example, x squared minus 1 over x minus 1. Let's work it out for x is equal to 1. So we have to substitute x as 1. 1 squared minus 1 over 1 minus 1. We will get an answer of 0 over 0. Now, 0 over 0 is a difficulty. Why? We don't really know the value of 0 over 0. It is indeterminate. So we need another way of answering this. So instead of trying to work it out for x is equal to 1, let's try approaching it closer and closer. So instead of 1, we will have an input of 0.5. Then we will get an output of 1.50000. And as we have an input of 0.9, we will get an output of 1.90000. And as the number goes or gets closer to 1, like for example, we have 0.9999, we will have an output of 1.9999. Now we see that as x gets close to 1, then x squared minus 1 over x minus 1 gets close to 2. We are now faced with an interesting situation. When x is equal to 1, we don't know the answer. It is indeterminate. But we can see that it is going to be 2. We want to give the answer 2, but cannot. So instead, mathematicians say exactly what is going on by using the special word limit. The limit of x squared minus 1 over x minus 1 as x approaches 1 is 2. So it is a special way of saying, ignoring what happens when we get there, but as we get closer and closer, the answer gets closer and closer to 2. As a graph, it looks like this. So in truth, we cannot say what the value at x is equal to 1 is, but we can say that as we approach 1, the limit is 2. It is like running up a hill and then finding the path is magically not there. But if we only check one side, who knows what happens? So we need to test it from both directions to be sure where it should be. For this continued example, we have x, an input of 1.5, and x squared minus 1 over x minus 1 is our output. And then, if we have an input of 1.5, we will get an output of 2.50000. And as it goes on and on and on. Also heading for 2, so that's okay. When it is different from different sides, how about a function f of x with a break in it like this? The limit does not exist at a. We can't say what the value at a is because there are two competing answers, 3.8 from the left and 1.3 from the right. But we can use the special negative or positive signs as shown to define one-sided limits. The left-hand limit, which is the negative, is 3.8. The right-hand limit, which is the positive one, is 1.3, and the ordinary limit does not exist. Are limits only for difficult functions? Limits can be used even when we know the value when we get there. Nobody said they are only for difficult functions. Like for example, we have here the limit of x over 2 as x approaches 10 is 5. We know perfectly well that 10 over 2 is equal to 5, but limits can still be used if we want. Infinity is a very special idea. We know we can't reach it, but we can still try to work out the value of functions that have infinity in them. Let's start with an interesting example. We have here a question, what is the value of 1 over infinity? The answer is we don't know. Why don't we know? The simplest reason is that infinity is not a number. It is an idea. So 1 over infinity is a bit like saying 1 over beauty or 1 over tall. Maybe we could say that 1 over infinity is equal to 0, but that is a problem too. Because if we divide 1 into infinite pieces and they end up 0 each, what happened to the 1? In fact, 1 over infinity is known to be undefined. But we can approach it. So instead of trying to work it out for infinity, because we can't get a sensible answer, let's try larger and larger values of x. So we will start at 1. We have an input of 1 and we will have an output of 1.00000. So if we have an input of 2, we will have an output of 0.50000. And as our input gets larger to 10,000, we will have an output of 0.00010. Now we can see that as x gets larger, 1 over x tends towards 0. We are now faced with an interesting situation. We can say what happens when x gets to infinity, but we can see that 1 over x is going towards 0. We want to give the answer 0, but cannot. So instead, mathematicians say exactly what is going on by using the special word limit. The limit of 1 over x as x approaches infinity is 0. And it is written like this as shown in the monitor. In other words, as x approaches infinity, then 1 over x approaches 0. When you see limit, think approaching. It is a mathematical way of saying we are not talking about when x is equal to infinity, but we know as x gets bigger, the answer gets closer and closer to 0. Evaluating means to find the value of think. Evaluating. We have many ways to get an accurate answer to find the value of the limits. First, just put the value in. The first thing to try is just putting the value of the limit in and see if it works. In other words, substitution. Let's try some examples. For example number 1, we have the limit of x squared minus 1 over x minus 1 as x approaches 1 is equivalent to 0. We have to substitute the value of x, which is 1, and we will get the answer of 0. It is indeterminate, or we could say undefined, so it won't work. For the second example, we have limit of x over 2 as x approaches 10 is 5. We got the answer 5, which is the limit, and it works. It didn't work with the first one, but the second example gave us a quick and easy answer. For the first way to get the limit, we just have to substitute the value of x. The second way to get the value of limit is to find the factors. We can try factoring. For the given example, which is the limit of x squared minus 1 over x minus 1 as x approaches 1, we can factor the x squared minus 1 into x minus 1 times x plus 1. So, we can now cancel x minus 1 as the numerator, then cancel x minus 1 as the denominator. So, we will get the limit of x plus 1 as x approaches 1. So, by doing this, as we get the factors and canceling the value, now we can just substitute x equals to 1 to get the limit. So as we substitute the value of x, which is 1, we will get the answer 1 plus 1 is equals 2. So the limit is 2. The third way to get the value of limit is conjugate. When it's a fraction, multiplying top and bottom by a conjugate might help. The conjugate is where we change the sign in the middle of two terms like this. So the sign is positive, you will change it to negative. So 3x plus 1 will become 3x minus 1. Here is an example where it will help us find the limit. We have limit of 2 minus square root of x over 4 minus x as x approaches 4. Evaluating this at x is equals to 4 gives 0 over 0, which is not a good answer. So let's try some rearranging. Multiply top and bottom by the conjugate of the top. So first, we have to multiply top and bottom by the conjugate of the top, which is 2 minus square root of x over 4 minus x times 2 plus square root of x over 2 plus square root of x. We can simplify top using a plus b times a minus b is equals to a squared minus b squared. So we can simplify the top further, and we will have 4 minus x over 4 minus x times 2 plus square root of x. So now we can cancel 4 minus x from top and bottom. Then we will get 1 over 2 plus square root of x. So now we have the limit of 2 minus square root of x over 4 minus x as x approaches 4. We have 1 over 2 plus square root of x. As we substitute 4, we will have 1 over 4. And that's the limit. Thank you for watching this video. I hope you learned something about limits.